So production. So that is why you are seeing a negative. So this is just an example of how multiple factors can affect your potato production, right? You are able to see my slide now. Again, in the startup example, we have multiple factors that are affecting the profit of the company. So again, as I said, data science has no limit. It can be implemented to the farm production of the potatoes, or it can be implemented to the research and develop, researching which startup companies made profit based on what factors that were including. When we search a job on Indeed, we look at multiple things. Whether the job is, we put so many filters when we are searching. Whether the job is online, or whether the job is in person, or whether the job is hybrid, right? That's where you will decide the salary for yourself these days. You are not just going each day over there and doing your job and coming back. So online, maybe you will get a little less pay, but you are saving some money on gas and everything. So this is again a contributor. So there are so many contributors. They are not looking for where and how the companies performed and better. This is just a data set that we are talking about now. We are going to create a model which will decide or to start which startup company to invest and yield the maximum profit. So let's say I am the investor, and there's a startup companies data in front of me, and I have to decide out of these 50 startup companies, which company should I go and give them my money, so I will become their investor for them. I will become the stakeholder for that company. I will become the board of director for that company. How I will do that? I will give them this 50 startup companies and say that, okay, these are the 50 startup companies. This is the profit that they have made based on these investments they have done, and they are residing in these states. Which company you want to choose? Which companies which you want to go with? So this is just a simple introduction to multiple linear regression is. So the formula gets a little bit more complicated, but we are not going to shake away, because looking at this formula, it is not very difficult formula to live with. We already know from simple linear regression, the formula was y prediction is equals to b naught plus b1 x1. That's all we know. But we have more variables to tackle now: b2 x2, b3 x3, and bn xn, right? Now if you look at this one, this could be our b1 x1, b2 x2, and b3 x3, and b4 x4, and predicting the profit could be one thing that we are looking at. Now if I go back to the formula, if you remember what is y-intercept was, I mentioned that in linear regression, what was that? The base production of the potatoes, right? That 8 tons of potatoes that we wanted to publish. If you look at this diagram, base, regardless we put the fertilizer, yes or no. More production if you put 3 tons of fertilizer, less production if you have a lot of heat or hail or something like this happened, and more based on the rain that has produced this year. So all these factors are including, and that's why we are looking at these factors are contributing to the profits of the each company. We want to look at which company is the suitable company to be invested, which industry they belong. We are not looking at that. We are just looking at the dollar amounts that they have spent and which state they are residing. Now this is the formula that it is, but it is just an expansion of simple linear regression formula that we already know. So now production of potatoes is dependent upon three factors that we already know, which I have already discussed with you guys. So can we map something like this? B naught is the profit, and all the contributors R&D, admin, marketing, state, and what we will do with the state. It's a categorical data. And I think I will have to go back to what was categorical data, because when I was explaining simple linear regression and its uh, when I was mentioning about data cleansing in business analysis and design, I actually mentioned what is categorical data is. In simple words put together, what is categorical data is. The problem is R&D is a number, we are fine with that. Admin is numbers, we are fine with that. Marketing is a number, we are fine with that. Problem is this is not the numeric data. So remember we did what we did. One hot encoding for that. What was one hot encoding? Changing the, yes. So we need to change this into a numerical value, right? So this is a numerical value that we need to, this is the textual value that we need to convert into a numerical value. Thank you. So if I make this into a variable like this, that will be helpful for me. Right now there are discussing only two, New York and California. They're not talking about Florida. But if it would be Florida as well, then we will have three columns: 001, 010, and 100. Remember that I made all that categorical data into one hot encoding and made it into a numbers by adding 100. So that's what we need to do in the cleansing part of it. So for that, we will need to go back to that data cleanup, or the very first IPYNB file that I shared with you in business analysis and design course. Towards that, I give you that how to do the data cleansing. Remember, in the data cleansing, what we are doing, we are first missing the missing values, then we filled up those missing values with what? With the standardization, right? With the standardization, we put the mean in there, so that if we are missing a value, we put the means of all the values in that missing value, row. Or secondly, we did one hot encoding to put this with this textual based data, we need to convert it into a numerical data. We did that part. How we are going to do that here? We need to refer it back. We need to refer ourselves back to that file which I shared with you, or go back to that topic a little bit when we will be discussing that. So it could be something like this: 1 for New York, 0 for California, 0 for New York, 1 for California. And if it would be Florida, then we will have 011. Remember, that's what I'm mentioning: 100, 010, or 001 for those companies. How we are going to do that, that's a topic for when we are doing practically. But right now we are understanding the logic of everything, how the multiple linear. This is called adding dummy variables. That's why the slide is called dummy variables. It is nothing but converting all these row values into a distinct columns and giving them the value 100, which is by help of one hot encoding. The slide name could have been a little bit better, or name should be a little bit better. We are calling it dummy variables, but these are called dummy variables. But now if you're looking at it, it's just like a signal: 1 or 0, or 0 or 1. So I will be using B4 and D1, or dummy variable number 1. I'm not using B5 and dummy variable 2. I will tell you about that later on tomorrow, why we are just picking up 1. But for now, just think of it. We are not going to use this column at all. Definitely we need to get rid of this because of the data cleaning part. We already know that We need to get rid of this column to be a complete mathematical matrix model, right? Remember now how we used to learn mathematical matrices in our high school, but we never know why we are using matrices. Now we know why we are using matrices, because we are now converting the numerical data into the text-based data into a numerical data, and we are using it for our modeling in different data science algorithms. So that's why mathematics for kids right now is so much important now to learn in data science. Last slide for today. I'm going to continue tomorrow. So this will be just like a toggle for us. We'll be just using this B4D1, but I will explain a little bit more tomorrow on this one. Thanks for today.